Okay.
You got it now, buddy.
All right, sounds good. There we go. All right, so again here, the reason why padded mats are going to be used in gymnastics, all right, for problems like this that are talking about force and time of impact, we want the less force, which means we need the most amount of time. So the change in momentum is going to equal an impulse. So the only way to change an object's momentum is to apply force to it for a certain period of time. If you have a large time, you're going to have a small force. But if you have a large force, right, in a short period of time, ouch, not ouch. So we are looking for problems that are parts where we're going to wind up increasing the time of impact. Momentum is essentially just inertia in motion. It's an object's mass times its velocity. Inertia and mass directly related. And being in motion is going to give something a speed, or in this case, we're talking velocity. Which has the most momentum? All right, well, if we just drew out a quick triangle, momentum is equal to mass times velocity. Mass we measure in kg. Our velocity we're measuring in meters per second. And momentum we're measuring in kg times meters per second. So, which of these has the most mass? I'm sorry, the most momentum. Momentum is mass times velocity. Well, if you multiply these two together, you get 50. You multiply these two together, you get 40. Multiply these two together, you get 0. Multiply these two together, you get 250. So who has the greatest momentum? Now, number 4 just asks which one has the most mass. So don't overthink this one. Which guy has the most mass? 10 kilograms, 20 kilograms, 5 kilograms, or 100? You're looking at 100. Now, why does a baseball player follow through on their swing? All right, they want to change the momentum. The greater the change in momentum, the larger the impulse you have to apply. So you want to apply the largest force possible for as long as possible. You're looking here at letter A. So impulse. Impulse is equal to the change in momentum of an object. So it is letter A, but it's also equivalent to a force multiplied by time. So impulse can equal a force times a time, and it can also equal your change in momentum. Okay, remember the little triangle here, it means delta. Delta just means, all right, the change of. So the final velocity minus the initial velocity. Okay, because you can't change the object's mass, you're changing its speed. So in which case, here you're looking at letter C. It's both of them. It's both of them. Given a constant time, tripling the force will do what to the impulse? Well, if we just look at kind of this idea over here, and we don't change the time, right? If we think about it like a ones equation, time is a 1 but we triple F. So 3 times 1 is going to give us 3 times the impulse. So we're going to wind up tripling our impulse. If you double the impulse on you, it doesn't necessarily mean you're going to double the force. You're not going to change our mass over here. Okay, what happens is you're going to wind up doubling the change in momentum. Whoa. So a baseball player grabs a 0.20 kg baseball, changing its velocity by 30 meters per second. The ball comes to rest in about 10 seconds. So what is the force acting on the player's hand? Okay, so you're given mass, you're given velocity, they want F. So if I wanted to get F by itself, I would have to divide both sides by what? I would have to divide both sides by T. So you have mass of 0.2 kilograms. You have your change in velocity. All right, went from 30 to 0, so we're changing our velocity by 30 meters per second. And this happens all in 0.1 seconds worth of time. All right, so multiply the top, divide by the bottom. You're going to get 60 newtons. 60 newtons of force. In number 10, 22 kilogram object moving at 5 meters per second while there's a force being applied of 31.4 newtons. What time is necessary to change this momentum? All right, so just simplifying here, we want T this time. So to get T by itself, you would have to divide both sides by F. So you have 22 times 5. You're going to divide that out by 31.4. 3.503 seconds. So we're looking at letter D. What is the momentum of an object defined as? Mass times velocity, velocity times the time interval, mass times acceleration, force times the acceleration. Oh, what are we thinking here? You looked over at the triangle. P is momentum, mass times velocity. So we're looking for letter A as our guy. Okay, going on to number 12. The momentum change of an object. All right, so the change of momentum is equal to the impulse acting on it. So if you had a freight train moving along with a certain amount of momentum, if it were to roll at the same speed but had twice as much mass, the momentum, what would happen? It would double. All right, so you're looking at momentum time is equal to mass times velocity. If we treated everybody like a ones equation, velocity doesn't change, so it's a 1, but they said we double the mass, making it a 2. 2 times 1 is going to be 2 times the momentum, all right, or doubled. From the triangle on the Other side. Mass times velocity is going to give us momentum. So you're looking here at 2 times 3, which is going to give us 6 kilogram meters per second, or letter C. The reason why padded dashboards are used in cars. So remember that whole thing we did on the front side? Looking at this. The impulse is equal to a change in momentum. We want longer time because it's less force. So the padded dashboards, what is the reasoning here? What letter are we looking to get? They increase the time of impact in a collision. So we're looking at letter C. Number 16, you're given momentum of 20 and a mass of 4. So P is 20, M would be 4. 20 divided by 4 is going to give us 5. So we're looking here for letter C. A table tennis ball gun is fired. Compared to the force on the ball, the force on the gun is the what? It's going to be the same. It's going to be the same here. A boxer this boxer learns to move their head backward when they see they're going to receive a jab. All right. What does this motion accomplish? It would increase the contact time, which would wind up decreasing the force. So they're moving back with it. Moving back with it. Okay, a 2 kilogram ball is thrown upwards at 4 meters per second. What is the ball's momentum? Using the triangle again, mass times velocity, you're given both of those, so you multiply them together, and you're going to get 8. Right, because P is equal to M times V. Mass was 2, velocity was 4. In here, you have a mass, you have a momentum. So to get the speed of the ball, to get V by itself, cover it up, and then it's going to be momentum divided by mass. So if the momentum is 39 and the mass was 5, you're going to divide out, and you should get 7.8 meters per second. Okay, an object that is not moving does not have momentum. Is that true or false? If it's not moving, it absolutely cannot have momentum. So we got true. A change in momentum is created by an impulse. Yep. Two pool balls or billiard balls colliding is an example of an inelastic collision. Is that true or is that false? Remember, inelastic, the objects stick together. Do pool balls, when they hit each other, stick together? Nope. So, yeah, nah, that's a false. God bless you. Bless you.
Thank you.
Something that does not have mass cannot have momentum. Well, true, but I don't think anything can't not. But regardless, yeah, if it doesn't have velocity, if it doesn't have mass, it can't have momentum. Yeah, I mean, pretty much there'd be nothing there. So yeah, looking here. When two train cars collide and then connect together as they roll, this is an example of an inelastic collision. Well, yeah, they get stuck together. So that would be your inelastics. Momentum is conserved in only elastic collisions, not inelastic ones. That's false. Momentum can be conserved in either of them as long as there's no external forces acting on them. Impulses are less when objects bounce. So it was from a video that we had watched. We had two balls, right? The one dropped and hit right away and landed. An identical one, okay, but if instead of it slamming and just stopping instantly, it bounces a little bit. Same mass, they both have the same velocity originally, so they're both going to have the same change in momentum. So the impulse is going to equal the same. They're going to wind up being the same. One of them is going to have a longer period of time where it's changing. So in that case, it is false. The impulses would be the same, regardless. If an object's velocity is doubled, its momentum is decreased by half. No. The faster it's moving, the more momentum it's going to have. So that is also a false. Airbags in cars save lives by decreasing the time of impact of our body on the car. Do airbags decrease the time of impact?
No, increase it.
Yep, correct. They increase it. By increasing it means less force, less ouch. So that's better for us. So that is then false. If no net forces or impulse act on a system, the momentum of that system cannot change. That's true. Yeah, it would be true. All right, guys, which equation is this? Elastic or inelastic?
Elastic.
Inelastic, because they get stuck together. So just based off the picture itself. All right, this one would be your inelastic. What about this guy here? They're not stuck together, so that would be your elastic. So when you know what the equation is, write the equation underneath it. So we're looking at the inelastic equation. So you got M1V1 plus M2V2 equals M1 plus M2 times VF. Now, once you do that, guys, you're putting everybody in the right spots. Mass the first guy times the velocity of the first guy. Mass the second times the velocity of the second. These two dudes added together times VF. And now multiply out and simplify and reduce here. These two guys multiplied together are going to give me 29,000. $465 plus anything times 0 is 0. Adding these two dudes together, I get 4,800 VF. So to get VF by himself, divide both sides by this 4,800. So the final velocity should come out to be roughly 6.14 meters per second. The next all right, we're looking at an elastic collision. So once you have your picture, all right, you write out the equation underneath it, makes it easier. M1 V1 plus M2 V2 equals M1 V1 prime plus M2 V2 prime. These little apostrophes or the prime, that just means the velocity of the objects after the collisions. All right, so plug everybody in the right spot. 13 kilograms to the mass, speed is 6, plus mass of the second character here, 4.5, times its velocity of 4. Mass of the first dude didn't change, so it's still this 13. But it now has a velocity of 3.5 meters per second. Mass of the second dude did not change. It's this 4.5. And now we don't know what this is. We don't know the new velocity for the second object, or this V2 prime. So let's work these out, simplify these out. You get 78 plus 18. It's going to equal 45.5 plus this guy, 4.5 V2 prime. Okay, let's add everybody up together on this side. 96 subtract both sides by this 45.5. That's going to leave me on this side with 50.5. All right, it's 4.5 V2 primes. Divide both sides here by the 4.5. And that will give us a new speed here of 11.2 meters per second. Okay, this guy here is just done like we did the first one of these. All right, it's an inelastic collision, solving for VF. And then these last couple here. So if a constant force of 4.5 newtons acts on a 7.2 kilogram object for 10 seconds, what is the change in the object's velocity? So the equation is given to you here. This symbol right here means the change of. So you're finding just delta v, the change of velocity. So you have force, you have time, multiply those two together, and divide by the mass. So the force was 4.5 newtons. The time was 10 seconds. Mass was 7.2 kilograms. Right, plug that into your calculator, and you should get a change in velocity here of just 6.25 meters per second. In the second one of these, they want to know what the force necessary is in order to change the velocity of a 2 kilogram object by 7 meters per second in 0.10 seconds. So the equation is here, F is equal to mass times your change in velocity divided by the time. So the mass was what? 2 kilograms. The change in velocity, that's delta V. So change in velocity, 7 meters per second. And divide this by the time, and the time is 0.1 seconds. This should give us a force of 140 newtons when you multiply these guys out. And the last one, on the mass of this object, if the velocity of it changed by 1.5 meters per second when a 3 Newton force acted on it for 4 seconds. So that the equation here is a little small. Force times time divided by your change of velocity. So the force was 3 newtons. The time was 4 seconds. And the change in velocity, delta V, is change in velocity. It's just 1.5. And that's going to kick out an answer here of 8 kilograms. Now the final answer to this guy, I'm not doing all the work right now, but should come out to be 7.3 meters per second as your VF. So make sure you have the work, get the work done to make sure you get that answer to match it up. Okay. So guys, that is going to be your test review.